Thanks, Betty. As Betty mentioned, my name is Rick. I'm the Director of Engineering at Solo. And today we're going to talk through a realistic operational workflow that you could do in your Gloo installation for doing Canary releases and upgrading different services in your application. So what's the goal? Our goal here is to successfully deliver new features frequently to end users. We want it to be as much of a continuous delivery process as we can. And ideally, we can decentralize that process. So we could define a way for different teams to potentially manage their own upgrades. And Gloo gives you those primitives. We'll look into the configuration for this, but a lot of customers and people that are building out platforms with Gloo have asked, what are the specific workflow steps that I would do to take advantage of Gloo's features towards this goal? And specifically, when we're talking about production environments, we're worried about some challenges related to how do we minimize risk, avoid downtime, and generally avoid disruption, which includes detecting when there's a problem. So how would we, how do we actually do this operational workflow in a safe way for production? And obviously, the reason we're kind of utilizing the API gateway is we've got likely a lot of different services, potentially in a fairly heterogeneous environment. It's complicated to start to work through and define these workflows. And there's a lot of different independent moving parts. So what is Canary releasing? It's basically a technique it's a technique where you start to roll out a little bit of traffic to a new version of a service with the goal of eventually kind of progressively delivering that new version, at least in this workflow. There's other use cases you might utilize similar techniques if you were doing, let's say, A/B testing and trying to gather data. But for our purposes here, we're really talking about a safe way to gradually expand the scope of our testing so that by the time we've shifted traffic over to a new version of the service, we can have confidence. And specifically, it works by deploying a new version alongside of our existing version, and then routing a little bit of traffic, we'll see. And then once we're satisfied, as we shift more traffic over, we can kind of finish that process and decommission the old version. There's a lot of different ways that we can accomplish this, but today my goal is really to present a concrete workflow that you could imagine applying within your organization and on top of your platform. So in case you're relatively new to Gloo, Gloo is an API gateway. It's cloud native, built on top of Envoy as the proxy. So if you're thinking about your application, requests are coming from users through to different services as the entry points to your application, and Envoy sits in the middle, usually providing things like authentication, maybe rate limiting, maybe transcoding the protocols. For our purposes, we're also going to leverage a few Envoy features called subset routing and weighted destinations. But what Gloo is a control plane. So Envoy requires configuration. What Gloo can do is dynamically watch the configuration that users are authoring. We'll see those examples in my demo. And as you're making changes to the config, it pushes those out, translates them into Envoy, and updates Envoy dynamically. So you use Gloo to really connect users to your application while doing it in a secure way. It's also a nice kind of entry point when it comes to observability, as we'll see. So in this webinar, I'm going to advocate a two-phased approach to Canary releasing, where the first phase, it's very targeted, kind of shifting a tiny subset of the traffic. In our example, it's going to be based on the value of a header in the request, though we could kind of select that traffic in different ways. And the purpose of that first phase is really initial correctness testing. Let's make sure things look okay. for maybe me or for a specific user. Then in phase 2, once we're satisfied on the correctness, we will start to shift more load over to the new version. And at that point, you're really monitoring kind of metrics, trying to figure out is the performance of the new service meeting our expectations? Has there been any kind of regression? And assuming that goes well, at the end, we'll eventually decommission the first version. For this demo, I'm going to use a service, just a simple echo service. So it's going to echo back the version that it is. And in that way, we'll be able to see easily which version that we're actually sending traffic to as we go through this exercise. We'll deploy the 2 versions side by side at some point in the workflow because we want to do that kind of side by side testing, and eventually we will decommission V1. Great, so with that, I'm going to shift gears into the demo. So I've gone and installed the Echo application. We can see the manifest here. Basically, it's, I'm running it in a namespace called Echo. It's a very simple container. I actually borrowed it from HashiCorp. All it does is echo back the text that you provided in a program argument. And I've put a Kubernetes service in front of it, just called Echo. So this is the Kubernetes endpoint that will be actually, having Envoy forward requests onto. Now, to start, I'm not deploying 2 versions. I'm just going to deploy 1. In addition to this, I need to actually create a route in Gloo. So we want to define first the route itself. It's in Gloo. The way that you define a route is you create virtual services. So we've got a route that's defined here, and it's essentially routing any traffic. This is a demo, so I'm just matching on the star domain. So any request hitting Envoy with any host, and because I've used the path prefix / really any path, will get forwarded and routed onto this upstream called Echo. What the upstream is really the destination for traffic. So here we're referencing the service port, the service name, namespace, and port. And we'll use this in a second, but I just wanted to call it out here. In our upstream definition, we're leveraging a feature called subset routing. And so basically, we'll define subsets on the deployments using labels. In this case, we're going to use a version label. So if we go back and look, we'll see each, our actual pods that get created, our deployment has this V1 version. And if we deployed a second version, we could deploy V2. And the subset definition in our upstream, by kind of describing that version is a way to break up that destination into different subsets, we can start to utilize that in our Gloo routes, as we'll see shortly. But I just want to first show you kind of our cluster. So I've got a GKE cluster running. So this is a Google Kubernetes cluster. I've deployed in advance Gloo, as well as a few other things, which you can disregard. I've been doing some service mesh testing. But I've deployed Gloo, and I've also gone and deployed that Echo service. So if we look in our Echo namespace, we should see, we've got the service running, we've got V1, the V1 deployment, and there's one pod that's the container that's running. Finally, if we curl, so I'm going to here use GlueCTL to just easily grab the address for that proxy. So and we can see we're getting kind of that result back. So we're seeing a request to this URL hitting basically our container that we've defined here, and it's returning that response that we hard-coded version V1. Now, just as an aside, just to show what this is doing, this is resolving to a service IP address in the form of a URL. And if we look at the services in our Gloo system namespace, we can see that I've deployed Gloo with the gateway proxy as a load balancer service, and that's the external IP address. So I'm issuing requests to the proxy because of the routing configuration. Any request to this IP address hit our virtual service, and any path hit our specific route definition. That's why this request returned us version v1. Okay, so we're all set up, but we now have v2. We want to introduce a way to start testing v2. The first thing I'm going to do is update our route to take advantage of that subset feature. So basically, going to change the route that we had defined so that specifically it only forwards that request to the subset of pods backed by that upstream that have this specific label associated with it. Now, I'll apply this and we'll see. We expect at this point really no change. We only have v1 deployed, so if we go back and curl, we're still getting back v1. So that didn't really change the functionality, but we can start to play around with new versions in the namespace without worrying that traffic is going to be sent to them. So that's what we're going to do next. We're going to deploy v2, which is essentially the same as our v1 deployment. The main difference is we've labeled it with that version so that we know that it's part of the v2 subset. And then we've also updated the return, basically the program argument, so that when we curl this, it returns version v2. So let's deploy that first. Let's make sure that our curl requests, we picked up the subset definition in the route, so we can continue to see the behavior of the application as it was before. We didn't start accidentally routing traffic to this just because we deployed it. But now we can look at what would it take to define a route that does send traffic to that subset. So at this point, we're going to introduce a new route on our virtual service. This is what we had before. So we had the single route matching on anything. What our new route is going to do is it's going to have the same matcher with an additional header that's required. And specifically, we're going to look for the header stage canary. So basically, if I provide that header in my request, it'll get forwarded or routed based on this definition. If that header isn't present, we'll fall back onto this route. And the routing action for when that header is present is that we're going to forward to the same upstream, but this time we're going to use subset v2. And so this is how we're kind of multiplexing the request based on whether this header is present to either v1 or v2. So let's see how that works. We've updated our virtual service. Let's curl. So again, as before, we didn't change the behavior of the application, but if we provide our header, we start to see requests going to v2. This is good. This gives us a way to selectively start sending some traffic to v2 so that we can really see what's going on. And let's say at this point, I instruct, maybe as a team, we're going to do a round of correctness testing or QA. We can leave this as is for however long we want until we're comfortable that this is behaving as we expect. And I'm not going to get into it in this demo, but I do want to paint a picture. There's a lot of ways that we could populate this instead of expecting the user to provide it. A good example of that is you could imagine if a request comes in with a JWT token that's valid based on how we authenticate JWTs, and that token contains a claim that says we should send the request to Canary. We can move that claim into the header if it's a valid token, and then we can use that as the header, or that we can have that basically that filter provide that header instead of the user. That's just one example. There's other ways that we could do this, and control kind of how we're matching to send traffic to the subset. Great. So that's the end of phase one. We're kind of happy. We were able to kind of feel confident in V2 of the service based on our initial testing. So we're ready to start kind of shifting into phase two, where we really progressively roll out or deliver traffic to that new version until we're all the way to 100%. I'm going to build off of the virtual service that we had before. Specifically, what I mean is I'm going to leave that first route intact. You could imagine during the second phase, you still want the ability to kind of selectively send traffic specifically to V2. So this might be a nice to have kind of route to maintain. But I'm going to change our fallback route, our kind of default route. So instead of just routing to the specific single destination of that upstream, I'm now going to utilize a feature called weighted destinations. So basically, Gloo lets you define multiple destinations on a particular route. You can define the weights associated with it. So how you would really kind of shift, for all the requests coming in that match on this route, how much of them should I send to one or the other destination? And these could be different upstreams, they could be different destinations. But in our case, what's different is just the subset. So we're still utilizing subset, but now we're utilizing it with weights to increase the load towards V2. In our first iteration of this, you can notice that I've configured it so 100% of traffic is still hitting V1. So really, I want to get this set up and just show you, we can apply this. We don't have to start shifting traffic immediately. So we expect this continues to behave as before. If we curl with the header, we're getting Canary. If we curl without, we're getting V1. Great. Gloo's behaving as we expect. Now, in a progressive delivery scenario, you're probably going to take a much more fine-grained approach to the weights. But in our scenario here, for demo purposes, I'm going to immediately jump to sending half the traffic to V2. So you may want to start with a percent and maybe increase it to 5%, 10, 25. You'll want to come up with some scheme for actually deciding what steps along the way you want to test at. There's great tooling out there in the open source community from our friends over at Weaveworks. There's a tool called Flagger, which helps you automate the progressive delivery. So it helps you automate the changing of the weights and to get to the final kind of desired state and capturing kind of metrics, or you can define kind of business metrics that you care about to evaluate during that process. Let's apply this route. Let's see how it works. So now what we're seeing is we're getting some requests to V1, some to V2. Now it should be about 50-50. I'm seeing it not quite that, but I'm also, this is a good time to introduce, I'm running a performance test in the background here. This is actually a bit of a risk because doing a live demo here, but what I wanted to show is we can start to, send if we're sending a significant amount of load through the proxy, what happens? And to do that, ultimately, this is the reason I've deployed Enterprise Glue. So what I've done is I've kind of set up a couple scripts that are pushing as much traffic as they can to the proxy. And at this point, as we saw, 50% of the traffic is going to the new version V2 of the service. So in a scenario where we're really trying to evaluate how is the new version performing under load, we can jump into the dashboard and we can really compare what did things look like, for V1 versus V2. You'll notice that I've got some, so just to kind of interpret how I'm perceiving these. Our demo started, or our kind of webinar started at 1. During this time, I was doing some testing, so I was kind of taking up and down Gloo, taking up and down our Echo upstream. But since we've started, we really don't see any interruptions. In fact, if we zoom in, as we've been modifying the weights, we see kind of peaks and valleys, though no rejected requests from Envoy. So it's more of a function of my internet connection, most likely. And what we can see is we're issuing, between 100 and 200 requests per second on average. And all of them are coming back as 200s. That's great. That's what we expect. The average request time is staying pretty low. It's actually quite low. We're talking fractions of a millisecond. And overall latency, so overall latency through the proxy, these requests are coming back really fast. And that's good. That's what we expect. That's what we hope. In fact, in the background, Gloo does issue a few requests to Envoy as they communicate. So if we backed out and looked at a larger time interval, we can actually see as we added the load testing and started sending traffic to our real services, our Echo services, that's when we're getting a realistic assessment of Gloo, and the performance is great. So we're happy. I think at this point, we're pretty comfortable, and I'm going to fast forward the progressive part of the delivery and update the virtual service to send the other 50% of the traffic to V2. And as soon as I apply this, we should start to see, ultimately no requests are being returned with V1 anymore. So I've updated the route. Let's start to curl the request. And as we can see, we're now seeing version v2 for every request. And that's specifically because as we defined the weights, that's how we instructed Envoy to route the traffic. Now, at this point, we're routing 100% of traffic to v2. And if we go back to our dashboards, we kind of take a look at how things are going. Things look good. It's healthy. V2 is in good shape. So the final step here is, we just need to decommission V1. It's pretty safe to do that at this point without even updating our routes, because we don't really, we're not really sending any traffic to that container anymore. But I'm going to just update the routes first to keep it clean. So we can go back to a very simple virtual service definition here, where we're still using subset. We're just going to kind of keep that as part of our operational workflow. Over time, we'll be incrementing this version. But at this point in time, this is the state of the world. All of our traffic is hitting V2. So let's go update the route. Let's just, sanity check. Things are still okay. Great, we're looking good. And finally, we've updated our route. We don't really reference V1 anymore. So let's go and delete that. And let's just make sure things are still okay. As we can see, we haven't really seen any interruptions in our experience. The traffic's gone exactly where we expected it to. And even under load, we're pretty satisfied with the overall performance of the proxy. And we didn't really see any errors through Envoy, from Envoy's perspective, as we were kind of changing the destination for these routes. Great, so just a few closing thoughts, and then I'm going to shift over to questions. So, oops. you could see that everything I was doing here was driven by simple configuration changes here in the YAML. You know, as you probably know, Gloo has a fully declarative configuration. The entire state of the proxy itself can be constructed from these blobs of configuration that we're storing. Really, the source of truth here is this directory on my file system, or really it's stored in a repo somewhere. And I've been manually pushing it, but you could imagine a workflow where you're incorporating this into more of an automated CI/CD pipeline. Just by, and over time, you might be modifying this route definition. You don't really need to make any other changes in order to, achieve this progressive workflow. That's really nice. If we took advantage of some of Gloo's features related to decentralized configuration, where we actually make these virtual services more self-service, or we use delegation to allow people to kind of define the routing actions for a particular path. In that world, we could imagine different teams, the Echo team could own this object, or at least, this route definition altogether. That works out of the box today with open source Gloo. So, really, this should be a powerful tool to have in your toolbox for, even with open source Gloo, for kind of performing, a Canary workflow that's both, satisfactory for your production needs. We're not seeing any outages or interruptions in service. It's also satisfactory for your kind of platform needs. We're able to kind of represent these changes declaratively. We could store this configuration in our repositories, doing GitOps, or in our CD pipelines. Finally, there's, in fact, I'm gonna just open up the blog, and if we scroll to the bottom, I kind of had a few extra topics. So you could imagine, as we talked about, the next steps here would be, how do we actually automate this? Could we integrate tools like Flagger? It's great that I can do this manually, but it would be even better if I could have automation looking at those metrics that I cared about. And we can, out of the box with Flagger. And ultimately, I've done this demo entirely in Kubernetes, but Gloo doesn't have to work that way. The core architecture of Gloo is based on the idea of abstracting away the storage, how you store your config, how you store your secrets, and how you discover service endpoints. So if we wanted to run this in more of a hybrid or off of Kubernetes scenario, we could. And that's really relevant to kind of our enterprise partners or our enterprise users who are dealing with more complex, underlying environments than what I was able to show here. But that's about it. If you have any feedback, would love to hear it. Can use as much of the rest of the time for questions if you have them. And generally would encourage you to try this out. I think this is a workflow that could form the start of a real production kind of operational, a way to manage your operations. And would love to hear your feedback. With that, Betty, I'll pass it over to you to see if there's any questions.
Yeah, so everyone, please go ahead and punch them into the Q&A window, and then I'll read some off to Rick here. And as what we'll do is we'll, as a follow-up to this session, we'll send out the recording, the link to the blog, and all those resources there. Be great to get feedback in the community Slack on if you tried this and if this works, and or variations that you're trying, because these are all these are recommended things to kind of get you started, but as we know, every environment is different, every app is different, your needs are different. So love to have that information sharing with the other users in the community as well. So a couple of things here. I think this is a good question in that does the gateway proxy work as an ingress? I think that's a little specific on the name of the different objects.
Yeah, so there's kind of two ways that question to interpret that. One is as in kind of an entry point, in the lowercase ingress sense of the word, I am using Gloo Gateway as my kind of entry point for the cluster. I have the kind of load balancer service, and so Google's providing me kind of this IP address that's externally available. So in that sense, yes, it's kind of an Ingress service here. In terms of being the kind of Kubernetes Ingress object, in this case, I'm not using that. I'm kind of using the gateway mode, and I'm doing that specifically to take advantage of some extra features that we can expose around subset routing, weighted destinations, and specifically through Envoy. But there is a mode of Gloo where you could use it as a controller for those capital I Ingress kind of our resources in Kubernetes. I just didn't, I didn't showcase that here.
Great. And then actually that's one good thing is if you have a question around, lowercase I Ingress or uppercase I Ingress is if you check out our Hoop live stream series, the one that we did, I believe it was last week, kind of talked about like Ingress versus API gateway, like, and kind of explaining the role of the proxies and the different modes. So that'd be a good primer because I think Ingress sometimes as a word is used for both, and it's good to get the clarification.
Yeah, and actually just one other thought on that, Betty. I think when we originally built Gloo, the V1 Ingress in Kubernetes was pretty limited in terms of the functionality. We are excited about the V2 version of this. There's a working group that's kind of defining a new Ingress definition. The initial kind of rollout of some of that was in kind of 1.18 of Kubernetes. So we're kind of closely following that, happy to utilize it, but where we find it to be limiting, we're also happy to utilize kind of our own kind of gateway object as the way to represent that.
Cool. And a good segue here is, with the routing that you've shown here, question is, will that also work with like TCP? Because we do support TCP proxying in Gloo, and can we do this kind of thing with that as well?
Yeah, I think so we do have plans to add more support for TCP proxying. I think a lot of the things I was showing were really required kind of HTTP like L7. So like matching, the phase one where I was matching on the header, we kind of need to define ways to make this work. And if we're just using Gloo as a TCP proxy, we are planning some work related to this, expanding the capabilities of our Gloo TCP proxy. So would be interested to hear, to get feedback or to open an issue to discuss kind of the use case.
Yeah, and that question was from Luke. Luke, if you're still on, and if you had some clarification that you could add on, how much support regarding routing to TCP that you were interested in, if you punch that into either the chat or the Q&A, we can dig a little deeper into that. The next question here is, does Gloo provide a way to incorporate a health check in the waiting such that a failure in the new upstream falls back to the existing version? So kind of automating, rolling back or, fallback based on the health check.
Yeah, it's a good question. So it's not something I've really tried. I think I see the value. So something I'd be interested to explore after this. My initial thought off the top on this is that I would want to look into the behavior of Kubernetes when the health check for a pod is kind of triggered. One thing that we've seen, or one thing to point out is there's some fallback behavior in our in Envoy. So if you're trying to route to a subset that doesn't exist, I believe it falls back to just the service selector as a whole. So it's kind of the fallback that you're describing. The bit of information that I don't know right now, but I'd love to figure it out is, does that fallback happen when the health check is triggered, and how do we actually configure that? So great question. I think it would be something that would be valuable to kind of incorporate into this workflow for exactly the reason you described.
Yeah, Scott, thanks for the idea for a possible additional demo that we can try out and build on this. The next one here is, can I use Kiali to interop with? So I mean,
Sure.
yeah, because you showed a Grafana dashboard, right? Getting the metrics with Prometheus. So are there, the question might be like with Kiali or any other kind of observability tools?
Yeah, and what we see, so I will preface this with saying that my bias is that Kiali. I'm kind of I assume Kiali is kind of a great GUI for kind of managing your Istio mesh overall. It's kind of packaged with Istio. That's been my experience working with it, specifically with Istio. And Glue and Istio work great together. So if we wanted to connect this to an Istio mesh, Glue can provide the Ingress gateway. It's more kind of feature rich. And we can configure Glue to have the proxy that Glue manages at the edge talk directly to the sidecars with MTLS and all that. So, would want to. I'm kind of assuming you're talking about in a scenario where we're also deploying Istio, and in that case, we certainly could. I think it would be interesting to look at to what extent can we bring in, metrics and other things from the Envoy at the edge that isn't technically an Istio sidecar, but is Envoy. It's publishing metrics. There's config that Kiali should be able to interpret. So a good question. That's kind of my initial thought off the top of my head.
Okay, great. And we've got one more question here on, can you explain the exact integration between Flagger and Glue? What exactly does it manage? And how does, the question is, how does Flagger route the traffic? Right? Flagger is like kind of automating the percentage, right?
Yep. Yeah. So you could imagine now that we have this primitive and you've seen this workflow, you could imagine that, and you could imagine the workflow being potentially much more involved, where there's maybe many more steps along the way in phase two. As I was mentioning, maybe 1, 2, 3, maybe you'll kind of do it with a Fibonacci increasing or doubling. So that's the part that needs to be automated. But to automate it, you also need to incorporate your metrics. And so that's kind of the two things that you'd utilize a tool for something like Flagger. You'd utilize a tool like Flagger to solve. So we've got the underlying primitives that we can be editing and that are publishing the right metrics. Now, how do we kind of orchestrate it? And so with Flagger, we could be kind of automatically updating weights on our CRDs. And we could be querying Prometheus with various business metrics that we define that could help really assess kind of our service, SLAs and things like that, our business metrics that we would use to feel confident at scale with our new version of the service. So those are the two things that we'd really utilize, to try and integrate with Flagger. I'll point, I didn't want to kind of overcomplicate our scenario here. There's ways that we can kind of separate, for instance, if we looked at, this, we could kind of pull this off into its own object. If we wanted to do that, that object in Glue is called an Upstream Group. And that gives us the kind of ability to granularly set weights just on that object. And then Glue will be responsible for kind of assembling all of that. I believe our integration with Flagger utilized that, so utilized it as an upstream group, but would be eager to kind of actually run through that in a follow-up. But yeah, those are the 2 points that we would be integrating to ultimately try and automate this workflow. You kind of need to have something that's changing the weights based on your workflow definition and ultimately based on the kind of results of computing different business metrics. And so you're kind of accessing this and you're accessing Prometheus.
And I want to say we have done a demo a while back related to an integration with Flagger. So what I'll do in the follow-up for this is also dig that up so you all can see the demo that we have. But in case that it was a while ago, so it might be there's been new features added to both our products as well as on the Flagger side. So I think it's a good opportunity for us to actually do a refresh of that. And Rick, as you mentioned, it could be a nice build, kind of a next thing to this tutorial that you've already done.
Yeah, and just to echo that, you know, one shout out to Stefan and the Weaveworks team. They've done a bunch of work recently with new versions of Flagger. I think they just released a 1.0 among other things. So definitely we're overdue for kind of looking, you know, basically kind of playing around with that integration again. And it would be a great follow-up here. Like, you know, now that we understand the workflow with Gloo, how do we automate it? My goal here was really, we've got a fairly large user community that, you know, people that are using Gloo now, and really want to kind of, and then a lot of those users and a lot of those, you know, platform architects and engineers and developers are kind of looking to us to help with defining these operational workflows. So as we define these, then we can kind of then work to automate them.
And then we have a more clarification on the TCP question. And this may actually be just specifically on just routing versus Canary. So that's the clarification. But the use case is having to expose a database endpoint for development purposes, but they wouldn't do that in production. So can we support that?
I see. Yeah. So let me think if I've got an example somewhere. Basically, the way
copy in the link to that specific area of the documentation.
Yeah, basically what you would do is Gloo has actually two abstractions that it uses to determine the overall configuration for Envoy, because Envoy is actually exposing off of different ports, listener ports, different sets of routes. So Gloo is both taking your routes and then also taking your gateway CRDs. That's kind of the CRD I was referencing that's different than the Ingress CRD. It's taking those two things and it's computing the kind of assembled proxy configuration. So what we've seen with, you know, what you can do to enable TCP with Gloo is you don't really need to define virtual services. You can kind of define a listener port and define the TCP right on the gateway object itself. And Gloo knows how to kind of translate that into your, into like the Envoy, the proxy config. I was looking for an example of that, but I would have to find it in the docs. But yeah, that's essentially how it would work.
Yeah, and then so we have the documentation link on this, and then there was also a blog post that Christian did in this specifically. So we'll add that in the follow-up as well, since we have very specific questions that people want answered.
Yeah. Yeah. So this is kind of what I was talking about. This is Gloo's intermediate representation. So we could have the proxy object that adds all your routes, or we could have kind of your just a very simple TCP listener that just tells you the destination. And the way that I'm looking for the gateway object, but oh yeah, the way that you would define that with Gloo is defining an object like this that actually specifies your TCP hosts essentially, and the bind port that you want to expose.
Okay, and we've got last question here. Back to kind of like the Flagger integration question is, does Flagger allow to routing traffic based on headers and not just weights? I don't know if that's, you know, the answer of that, if we should take that back to our friends over at Weaveworks.
Yeah, I'll be honest, I don't know. It wasn't I wouldn't be surprised, because I think Stefan and the team have like really thought through a bunch of different kind of use cases, whether it's progressive delivery in the way that we've gone through it, or A/B testing, or other kind of use cases for these traffic shifts. But I couldn't, you know, I haven't looked at it closely enough to give you a definitive answer. So it'd be, you know, we should follow up with the Weaveworks folks. I imagine they've thought about it.
Yeah, totally. And they are very active just online. And so, you know, Stefan's always on Twitter, as well as you can probably also find them in the CNCF community Slack. And so they're always answering questions in there. So that's also a plus. So actually, and then with that, Rick, if you just want to go to that last slide. in the presentation.
This guy or,
Yeah, and
or
so the very last slide, slide 11. Thanks everybody for joining. We've got some links here. We'll send out the slides and the recording as well, and some of the additional links that we mentioned to help answer some of the questions that folks had on the call today. But then to learn more, we've got the link to the Gloo product page, the tutorial specifically, the blog that Rick is mentioning, that's the link to the blog. And if folks specifically want to try this and or have a POC that you want help with, there's a link to request trial with us,
yeah,
and then hop in the community. There's a lot of the folks on this call today are folks that I know are Gloo users today, running in production. Others might be just kind of starting to explore this use case. We have a lot of great discussion and questions and answers happening in the community there. So join us in there.
yeah, just to echo that, one thing I would do, I obviously deployed Enterprise Glue here because I wanted to show off our Prometheus dashboard. But yeah, all of this could work with open source Glue. That's what the blog post was really geared towards. So, anyone here can give it a shot. And if you do have feedback, please, engage in Slack or over GitHub, or send me an email, whatever it is. We'd love to hear your feedback and kind of learn more about your workflows. Well, thank you, everyone.
Great, thank you, and see you next time. Bye.
Bye-bye.